Okay. Question 2. Alright, so this is for RC circuits. They want to know, this next question, they want to know what is the current a long time after the switch has been closed at time equals infinity. So, you know, the switch has been closed now for forever, and the current is just going to be going through here. So what happens when the current, you know, we initially saw that the current's only going to go through here because this is, the capacitor will just act as a wire, but charge will build up here. And once the charge builds up on this capacitor, and once it's finally reached its max capacitance for charge, like, there won't be any more current coming through here because this will now act as a disconnected wire at time equals infinity because, you know, all the charge has been built up. So now all you need to do is the current's going to follow this path all the way around here. It's going to ignore this disconnected wire, so all you simply have to do is to find the current at resistor 1 after a very long time would be just add up all the resistances, and then you'll get your answer. So find the request. So just find the total resistance real quick. So R1 plus R2 plus R3 plus R4 will equal equivalence. So 77 ohms plus 77 ohms plus 66 ohms plus 102 ohms is equal to 322 ohms, and that'll be your resistance equivalence. Okay, 322 ohms. So now that you know that, all you have to do is, you know, use Ohm's law of equal R over V equals R. V over R equals equal to I, which is the current. And because all of these are in series, current is equal to each other in series. So whatever the current is at one point at R4 or R3, it's going to be equal to the current at R1. So this, we have 24 volts divided by 322 ohms. And that should give us 0.07453 amps. And that's our current at each one of these resistors, but specifically we want to know it at R1. So that is our answer.